Okay, in the last video we talked about polynomials and their degrees and the properties of polynomials, and then we looked at graphing them. Now we're actually going to do an operation on polynomials that we're going to need for a lot of the stuff we're going to look at. And it's polynomial long division. So say we have something like x squared minus 1 divided by x minus 1. One thing I will say right at the outset, you can write division that way, which is kind of how we're used to seeing it. A lot of times when talking about polynomials, we'll just write them as a fraction, like this, and then we divide from there. So just be aware, a lot of times when I write stuff, and when you see it written out, it'll be written like this, that just means divide the polynomials. But the question is, how exactly do we divide those? And if you go all the way back to like 2nd or 3rd grade, or whenever they teach division nowadays, for the sake of argument, suppose you have 448 divided by 4. The way you divide is, well, let's see. How many times does 4 go into 4? 1. You put a 1 on top. 1 times 4 is 4. Then you subtract. That gives you 0. So you bring down the next 4. How many times does 4 go into 4? 1. You put that on top. You multiply. 1 times 4 is 4. You subtract. That's 0. You bring down the 8. How many times does 4 go into 8? 2. You multiply. 2 times 4 is 8. You subtract and you get 0. And that's really easy and you all know how to do it. And the point is, that works because it's called the division algorithm. It's how you divide. And that's actually how we're going to divide polynomials too. It will look slightly different because they're polynomials, but don't get lost in the fact that it looks messy because it's a polynomial. It works the exact same as this. You're doing the same thing. So, suppose we have x squared minus x minus 6 divided by x minus 3. I want to divide those, so I set it up. X squared minus x minus 6 divided by x minus 3. And now there's more than one term here, but we kind of start on the outside. We say, how many times does x go into x squared? Or more to the point, what do I multiply x by to get x squared? X. The only thing I would say now that I know it's x, put it above the linear term, the x term here. That just helps keep things organized. If you put it over the x squared, then it can lead to some confusion. But now, with our division, then we multiply. What's x times x? X squared. Now we have two terms over here, so we just multiply both of them. We did x times x is x squared. X times negative 3 is negative 3x. Now we subtract. And the one trick here is, this is subtraction of everything here. So do not just put a minus sign out in front. You have to distribute the negative in and essentially switch the signs of both terms. So that becomes negative, that becomes positive. Now you subtract. X squared minus x squared is 0. Negative x plus 3x is 3 minus 1, which is 2x. Now, since we finished with our subtraction, you bring down the next term, which is minus 6. And now, doing what we did before, we just go back to the beginning and start again. What do you multiply x by to get 2x? 2. So I put a 2 on top, make sure to put it above the constant term. Then I multiply. 2 times x is 2x. 2 times negative 3 is negative 6. Now I'm going to subtract, so I switch the signs of everything. Positive 2x becomes negative 2x. Negative 6 becomes positive 6. Now do the subtraction. 2x minus 2x is 0. Negative 6 plus 6 is 0. There's nothing else that has to come down, so I'm done. And I would actually point out, if we were going back to, say, the last chapter, x squared minus x minus 6, that's a quadratic. You can factor it as x minus 3, x plus 2, which is exactly what we got here. This divided by x minus 3 equals x, I said x plus 2, and then wrote x minus 2, is x plus 2. And we're done. We're going to look at several more examples of this to make sure we understand how the algorithm works. But again, just keep in mind, it's division, just like the division you did in 2nd and 3rd grade. So, first off, suppose we try this one, the one I wrote to begin with. X squared minus 1 divided by x minus 1. So, I write out my division. X squared minus 1 divided by x minus 1. And then I say, what do I multiply x by to get x squared? X. The problem is, there's no linear term, there's no x term here to put the x above. I could just randomly stick it right there. But generally that leads to things getting really messy and confusing, so there's a trick we use. When you are doing your division, on the inside of the division symbol, whatever the highest power of x is, you make sure you have every power of x all the way down to a constant term listed. If any of them are missing, we're missing the linear term here, we're just going to add a placeholder. So I'll do x squared plus 0x, because 0 times x is 0, so it doesn't change anything, minus 1. Now I have placeholders, I'm accounting for all the powers of x, so now I'm going to do my division. What do I multiply x by to get x squared? X. And now I'll put it above the x term. Now I multiply. X times x is x squared. X times negative 1 is negative x. I switch the signs of everything. Positive x squared becomes negative x squared. Negative x becomes positive x. If I do my subtraction, x squared minus x squared is 0. 0x plus x is x. Now I bring down the next term, minus 1. I go back to the beginning. What do you multiply x by to get x? 1. So I put plus 1 on top. Now I multiply. 1 times x is x. 1 times negative 1 is negative 1. I switch the signs of everything. Positive x becomes negative. Negative 1 becomes positive. X minus x is 0. Negative 1 plus 1 is 0. There's nothing left. And I'm good to go. And again, harkening back to what we already know, x minus 1 times x plus 1 is x squared minus 1. So we know that'll work. So let's see if we can have a little bit more fun with it. Suppose we have x cubed plus 3x squared plus 6x minus 2 divided by x minus 1. I want to do my division, so start on the inside. I check cubic, quadratic, linear, constant. All the powers of x from 3 down are there, so I don't need any placeholders. X cubed plus 3x squared plus 6x minus 2. And I'm dividing by x minus 1. Now, I just run through the process. What do I multiply x by to get x cubed? X squared. So I put that above the squared term. X squared times x is x cubed. X squared times negative 1 is negative x squared. Now I switch the signs of everything. Positive x cubed becomes negative. Negative x squared becomes positive. X cubed minus x cubed is 0. 3x squared plus x squared is 4x squared. Bring down the plus 6x. And back to the beginning. What do I multiply x by to get 4x squared? 4x. Multiply. 4x times x is 4x squared. 4x times negative 1 is negative 4x. Now I switch the signs. Positive 4x squared becomes negative. Negative 4x becomes positive. I do my subtraction. 4x cubed minus 4x cubed is 0. 6x plus 4x is 10x. Bring down the minus 2. Keep on going. Again, you just repeat the process over and over. What do I multiply? Gotta switch colors. What do I multiply x by to get 10x? 10. So I put a 10 on top. Multiply. 10 times x is 10x. 10 times negative 1 is negative 10. I switch the signs of everything. Positive 10x becomes negative. Negative 10 becomes positive. 10x minus 10x is 0. Negative 2 plus 10 is 10 minus 2, which is 8. And now in this case, there's nothing else to come down. If this was like second or third grade and you learned division, you'd probably put a decimal point there and add some zeros and keep on going. For this, we don't have to worry about that. That's just my remainder. So if you want, you can just write R8 for your remainder of 8. The actual more mathematical way of writing it is to essentially write it as a fraction like you would for a mixed number. And you do your remainder 8 over what you divided by, x minus 1. As far as it goes, this is pretty much how division works. It's always the exact same. Put everything on the inside. If you're missing any powers of x, throw in a placeholder, a 0x, 0x squared, whatever you need. Figure out what to multiply on top, multiply both terms, switch the signs of everything. That's generally the step that everybody has trouble remembering. They put a negative on the front and they don't switch the signs on the inside, and then this won't work. And then keep on going until you can't divide anymore. And then whatever's left over, if there's something left over, that's the remainder. Some of you may know how to do synthetic division. I don't really do that because I was never taught it in school, so I don't really know how to do it. So I'm not going to bother going over that. If you know how to do synthetic division, you can feel free to use that. You just need to be able to divide polynomials. There's a few more tricks to go along with this, but this is already a long video with all this division. So I'm going to make a separate, shorter video covering some of the other tricks we can get out of this.